Welcome back, ladies and gentlemen. Welcome to video part 3 for analysis of variance known as ANOVA. As promised in movie 2 for ANOVA, we are going to learn how to read all the numbers produced by SPSS for ANOVA. But before we go to that, let's refresh on the research question in our study here. So our research question is formulated this way. Are there differences among the students in 2018, 2019, and 2020 cohorts on academic performance for history subject? So basically, there are three layers or three levels or three groups in this study: 2018, 2019, and 2020 students. And we want to compare them on their history subject academic performance. So let's go to the SPS data. You can see here I coded 3 for cohort 20, 1 for cohort 19, and 2 for cohort 18. And in total, we have 81 participants in this research, and these are their history subjects results. So let's go to SPSS. We go to analyze. We go to compare means. We choose one-way ANOVA because there is one independent variable or a single factor only. And then we move dependent variable, in this case, a final history score, to dependent list. We highlight independent variable and move it to factors box. Do not click OK, ladies and gentlemen. We click option. We want SPSS to compute descriptive statistics to show us the test that assesses the equality of variances across the three groups. We want SPSS to generate a visual, a graph for us, and we want to exclude the missing participants with the missing data by highlighting exclude cases analysis by analysis. On continue, and finally OK. So we get what we asked for. You can see here we get the first table, descriptive table, test of homogeneity of variances table, ANOVA table, which is the most important one, and we get the mean plots graph. In order to explain all the numbers, let me switch to the PowerPoint slide because over there it's clearer. So you can see here, ladies and gentlemen, this is the first table, descriptive statistic. You can see the mean score. I would like to inform you that the total score is 100 over 100 for the history subject. So 2018 cohort obtained a mean score of 66.37. 2019 cohort 78.90. 2020 cohort, the mean score is 70.28. So it's clear that 2018 cohort performed much poorer than the other two cohorts, and the best performer is student from cohort 2019. This is useful, but as you are well aware that means tell us something, but not everything. We need to look at the ANOVA table in order to conclude whether students from the three cohorts significantly differ on a final history score or not. So if you go to the second table, is test of homogeneity of variances. So you can see the significant value. The p-value is 0.107. This p-value is bigger than 5%. It's bigger than 5%. So the Levin test, okay, Levin test is a test that assesses the equality of variances across the three groups. So since the p-value for Levin test is not significant, we can say that the variances for the three groups are approximately equal. So the second assumption of one-way ANOVA is not violated. So we can use ANOVA. We have a good reason to be happy because the second assumption, which is so important, is not violated. And the third table produced by SPSS is the ANOVA table. This is everything. This table is everything. If you look at the significant value for ANOVA, the significant value, the p-value is 0.000, meaning that it is less than 5% that we need in order to reject the null hypothesis. What is the null hypothesis, ladies and gentlemen? Yes, the null hypothesis is students from the three cohorts do not perform differently on the final result for the history subject. Since p-value is so small, we can conclude that they did perform differently. Well, that is all about the p-value, ladies and gentlemen. Let me talk about the F value, the F ratio. This is known as the Fisher test. Fisher test. When F value is big, you can expect a small p-value, as in this case. However, when F is small, let's say 1 or 2 or 3.3, something like that, p-value gets larger and therefore may not be significant. Where does the F ratio come from? Where does this number come from? A cool question, ladies and gentlemen. Well, it is the product of dividing the mean square for between groups and the mean square for within groups. And if you do that, you can get F value of 12.314. The next question is, where do the mean squares here come from? Well, each of them comes from the dividing between a sum of squares for between groups and its degree of freedom. In this case, 1905.18 divided by 2, the mean square is 952.59. And the mean square of within groups goes through the same steps. The last question is, where do the mean squares come from? Well, again, they come from the subtraction. The next question is, where do the sum of squares for between groups and within groups come from? Well, again, they come from the subtraction of each row score from the mean and then squared and then sum. Let's talk about degree of freedom a little bit because I skipped this. You can see between groups, degree of freedom is 2, and within groups, degree of freedom is 72. So where does 2 come from? Where does 72 come from? Well, you can see there are 3 groups. There are 3 groups in our research. So normally the number of groups is represented by English letter K, small letter K. So the between group degree of freedom is K minus 1. So 3 minus 1 is 2. How about within groups degree of freedom? Yes. As you can see, the sample size in our research is 75. 75 minus 3 groups, okay? 75 or the sample size minus K. In this situation, 75 minus 3 is 72. So before we conclude this movie on ANOVA, ladies and gentlemen, a final note on the concepts of between groups and within groups. In science, between groups refer to the real change or real impact, also known as the systematic change. Systematic change. However, within groups refer to noise or errors or something that naturally happens. As you can see in this particular study, the systematic impact is big, but the noise is small. This is the systematic impact. This is the noise is small. That is why F value is big and P value is very small. So another note, ladies and gentlemen, you can see the overall ANOVA is significant because P value is very, very small. I want to introduce a concept of ANOVA is a global test. Okay, it is a global test. So you can see significant value is small, P value is small. So students in the 3 cohorts perform differently on final history score. But ANOVA is a global test. Since it is a global test, it does not specifically tell us, which cohort perform differently. Okay, that is why, ladies and gentlemen, we need to run one local test or multiple local tests in order to detect the differences between group. Okay, this is the concept to take away. ANOVA is a global test. It tells overall that there is a significant somewhere. There are significant differences somewhere, but it does not specifically tell which cohort perform better or poorer than one another. So, ladies and gentlemen, we go to the last slide here for movie 3. So this is the mean plot that we asked for from SPSS. So as you can see, this is the y-axis, this is the x-axis. So the y-axis tell us about the mean score of final history, the final score for history course, and the x-axis display the cohorts of history students, and you can see from SPSS output, cohort 2018 average score for history course is 66.37, and 2019 cohort performed very, very well. The average score is 78.90, and 2020 cohort average score is 70.28. So mean plots is quite helpful because it visually, allow us to compare the standings of the 3 groups that we are comparing. So I hope, ladies and gentlemen, find this movie helpful, and I shall see you again soon.